part 2 of section 4.1. So let's take a look at one more example here. And in this one, they give you some information in a different way about the linear growth. So they're saying a car is bought in 2017 for $23,657, and then 2020 it is worth $18,500. So we need to create a linear model that can be used to determine the car's worth in future years. Well, 2017, that's a starting year. So this is when time is going to be equal to 0. And then 2020, it's worth 18,500. So this is when time is equal to 3. And from that, again, I always write down the formula, a linear model. So we're going to just go ahead and write down P of t equals this difference, or I'm sorry, P naught, start out in this form. So P naught plus TD, we're going to think about that. And the T is just a variable that'll change. So you always, really, in these problems, when you're setting up a linear model, you're looking for the P naught and the D. So P naught in this case would just be equal to 23,657. It's the starting amount. It's what the car was worth, or what you spent when you bought it, or starting amount. And the D, then we have a few different ways to get to the D, and for this I'm going to use an approach. If you've used a slope formula before, it's basically the slope, but what I'm going to do is find the new minus the old and then divide that by the number of years. And what this will do for you is give you an average rate of change per year. So the new value is 18,500. That's what it was worth in 2020. 2017, the old value, the starting value, was 23,657. And then you divide it by 3, since there's 3 years in between 2017 and 2020. And what you'll get out of that is negative 1,719. When you put this in your calculator, be sure to put the subtraction in parentheses so that your calculator knows to subtract first, then divide. And if you don't do that, you'll get a wrong answer pretty much every time. So we now know that D is equal to negative 1719. P naught is 23,657. So we can form a model, and we'll have this 23,657 minus 1719 times T. And that would be the answer to part A. So if they give you two different values, you can use this approach here to get the common difference. And if you've worked with slopes before, with linear equations in the past, you're basically finding the slope, the rate of change. So we can use the linear model to predict the car's worth in 2027. This is where you have to be careful here, because you're not going to plug in 2027 for the time, because you haven't had that car for 2,027 years. You need to remember that 2017 was when the time started. That's t equals 0. And then in 2020, you had t equals 3 years later. So continuing with this idea, in 2027, if you do a subtraction of that year minus the first year, and this is always what you can do to see the years in between, you would find that t is going to be 10 for this problem. So with t being 10, we just need to find p of 10, which is going to be equal to 23,657 minus 1719 times 10. And when you work that out, you get $6,467 would be the worth in 10 years based on this linear model. Okay, so that's pretty much it in terms of the linear growth, the different types of problems you might see, different things you might be asked to do with them, and different ways of getting that common difference, that changing amount per unit. So if you have any questions about this, make sure you ask so that I can help you.